So if we start with a basic function and we add a number to it, so f of x, and I try adding 2 to it. Oh, I don't know why the orange one's still there. That's it. F of x add 2. The function I chose, and the reason I gave you those points yesterday, is you've got to look at how each point moves. So f of x plus 2, each point moves up by 2 squares. Flash your microphone if you knew that was going to happen. Yep. Hopefully most of you should be quite familiar with that. So this is actually formally called a translation. And if you remember your translations that you were doing earlier in the week, translation vertically is a 0 and by the value of a. That's a vertical translation. If we go into the second one, so I'm going to delete this. Oh, hello, Soleil. If we come into the second one and look at what happens when you put a number inside the bracket. So I'm just going to delete this. If I do f, x, and then add a number inside. Why is it doing it green? I want an orange one. There we go, it's gone red now. So this number 1, if we look at the key points again, the points where it turned, what happened to them? Well, they've all moved left. Notice left, not right. What does that do to my value when I try writing it as a translation? Because we can see it's a translation. What happened? What would I say about my value A? What's happened to it?
It moved left.
Yeah, so what can you say, if I was to write it in here, are you saying that's the translation? What needs to happen to this to say that it's moving left, not right? So that's moved it left 3 places. How do I make it move right 3 places? Minus 3. So the number is the wrong way round. Now there is a good reason for that, and I'll show you it in a few moments. Okay, so the translation here, really be careful because this goes the wrong way. Now, I'll show you the reason why. If I take the other one above, and I'll take this one and I rearrange it, I could rearrange this as being y minus a equals fx. And now I've actually got the same pattern. This value here, when you look in the y direction, it's going the wrong way again. It's moved it the wrong way. That might help you realize why in the x direction it's minus. That's because this value is already with the x. If you move the value to be with the y for the y translation, you get that change of sign again. Okay, so it's linked to the idea of roots. If you remember in quadratics, we had the idea of a root of a function, things like x squared plus 3x plus 2 has 2 brackets, and each of the roots of this are the wrong sign. Okay, and the same thing is happening here in our function. When we rearrange this function here to take the translation part next to y to put it with the function, it then becomes a positive number. So you can think of them, if you were to move values around to put them with the y, it does the same pattern. It goes the wrong way in your mind. So that might help you remember things. Or just learn the basic facts. Okay, so let's move on to the next one. Hopefully you all got this one as well. So if we think about f of x, and I'm going to multiply it by 3. all the key points have got 3 times further away from the x-axis. So this point got 3 times further down here. This point got nowhere because it's a 0. All these points along the graph, this point goes to 3 times further away from the x-axis. What's that transformation called?
Stretch.
Nice one, Arjan. It's not an enlargement. Enlargement affects x and y together. This is only affecting the y direction. So it's got a couple of ways you can do it. You can say stretch in the y direction by a factor, by the value a. If that was a -1 though, it leads to another way of describing it. This is a reflection in, this stretch is actually a reflection in the x-axis. So another way to describe them is a stretch that's perpendicular to x by a factor of a. Okay? All right with those ones? Flash your microphone if you're okay and it's the sort of idea you're expecting. Yeah, the multiplications most people sort of get. Right, what happens if I do a multiplication inside the bracket? So if I do f bracket 2x, now it's made it a little harder to see at the moment, so I'll press the equals and change the colour. Come on, change the colour. Why is it not? Oh, I've gone through enough colours, that's why it's done that. Okay, so we start with the green. What's happened to all the points here? Well, if I go to this point here, it's gone down to from 2 down to 1. This point here has gone halfway towards the y-axis. This point here has gone halfway towards the y-axis. So this has been stretched in which direction? Yeah, it's an x direction. What's the factor though? I put in 2. What happened to the distance going from the green to the red? I went from the point 2 to 1.
-1.
-1. We didn't start here though. At -1 it became -1/2. This one's about 1.2 and it became 0.6. What have I done to those numbers? If I try doing it by a 0.5, my 2 has become 4. My 1.3 seems to have become 2.6. My -3 has stretched across to -2, from -1 to -2. It's actually doubling when I do a half. It's the 1 over the a, it's the reciprocal. It goes the opposite way. So instead of doubling, you half the x direction. Instead of multiplying by 9 in the x direction, you divide by 9. And just like I showed you before, if we were to rearrange this one so that we get the coefficient with the y, because it affects the y part. So the thing we're multiplying here, if I rearrange it, I get 1 over a of fx, y equals fx. And we're getting the same pattern now. The number that multiplies on the outside becomes a division when it goes to the y. That tells you you've got a reciprocal of this to give you the stretch in the y direction. So this value at 1 over a is the opposite of what happens in that y direction. So both of these, by rearranging it, you can get the same pattern. Both of them will actually move the wrong way because it's linked to things like roots. Last bit before I set you off to do the exercise. This thing links back to something when we're doing quadratics. And one of the questions I've given you, they say something along the lines of, we have a function fx, which is given by x squared minus 6x plus 8. And it says, write it in the form of x minus a, did it say minus a or plus a? They say plus a, plus b. What's that movement that's called? What's the process called to take that function and turn it into this? No one remember? Complete the square. What's the process for complete the square? What do you mean you, Lunara? Can you remember the process of completing the square? X squared minus 6x plus 8. Something in there turns into a squared. So I'm going to take the x down. If I'm going to square this bracket, this number here multiplies by x twice to give me my minus 6. So what number do I need in here, in this gap? Yeah, Alja, it's just the minus 3. Because if we think about multiplying this out, we get x minus 3 times x minus 3, which gives us x squared minus 3x minus 3x, well, there's my minus 6, but I also get a plus 9. So on the outside of this, I've got to correct for the plus 9. So I subtract the minus 9 and then add on my plus 8. Don't forget you've got to make the correction first. So I now simplify this to being x minus 3 squared minus 1. And if we look at this now, what's that as a translation? What translation does the minus 3 do?
To the right.
Okay, so that gives me a 3 to the right. What translation does the minus 1 do?
Three up.
Look at the minus 1.
3 down. No, 1 down.
1 down, so it's 0 minus 1. So overall, this actually leads to a 3 minus 1. So if I delete that function, and I put in the function here, we had x to the power of 2 minus 6x plus 8, minus 6x plus 8. There we go. There's my graph. If I draw in a normal quadratic, the plane quadratic, if we take the key point on the quadratic and translate it, we translate it 3 to the right, 1 down. I can do the same thing to this point. Translate 3 to the right, 1 down. 3 to the right, 1 down. So that's how you can link graphs back to their original functions. All right. So you've got page 507. I think I said question 1, 2. You can have a look at question 3 if you want, but question 6, 7 and 8. Question 8 uses this, you've got to do the completing the square. Okay?